Okay, so I've been learning some higher level math, and I learned about the binomial theorem, and that kind of intrigued me quite a bit, and I kind of wanted to show you how it works. And I've been like kind of learning calculus, learning some higher level math, and been thinking about how logic is basically what mathematics is reduced to, or how logic is the foundation of mathematics. And I myself am a logicist, and I've been thinking about doing actual mathematics and seeing how in how big complicated stuff like, say, the definite integral or the sigma notation or the summation can be reduced down to logical concepts or logical thought. And so I kind of wanted to, I've done probably 3 different problems having to do with binomial theorem. And let me just talk about what the binomial theorem is, and show why I think it's amazing. So it's also called binomial expansion, in that you can take a simple binomial with 2 terms, say x minus y to the 4th, or something like that, and you can expand it into something like that. And there's a lot of reasons that one would do this, or why one would need the binomial theorem, but I'm not really interested in that right now. I just want to show you how it works, because I think it's freaking fascinating, and how fascinating it is kind of makes me think of maybe sort of a mathematical realism, and how it almost seems absurd how something as beautiful and amazing as this could, be idealistic or anti-realistic thing. So, as I said before, the binomial theorem is that a 2-term binomial, or 2-term algebraic expression, thus a binomial, specifically raised to a power which is n, that leads to the summation. The sigma notation specifically is referring to a geometric series. Usually, well, it can refer to it usually is a geometric series, especially when it's used in higher level math, including calculus. But what this one is, this is the binomial theorem. This is a formula where the summation, there's a summation where n is the index, k is the starting point, and where n choose k is how we get all this. I'll explain n choose k here in a second. And there's also a to the n minus k times b to the k. And what does n choose k mean? And this is partly from combinatorics, but combinatorics is not something I'm really interested in right now, but this is really important and nice. And n choose k specifically means this formula right here, where n factorial over k factorial times n minus k factorial, and that little exclamation point is a factorial, where, say, any number put in place of n is a factorial, and that's say 7 factorial right there, which happens to be 5040, is 7 times 6 times 5 times 4 times 3 times 2 times 1. It goes all the way back times all of those numbers, and it is very helpful in things like this. So n choose k pretty much is referring to this formula right here. And what we do, let's say I chose for this video to talk about this theorem, I chose a plus b to the 7th power. And what you would do is you would pretty much take this formula, this part of it, not including the summation. The whole sigma summation thing is referring to how this is a series, where a sequence is something where you have a succession of numbers, where a series is where all those things are added. And what you do when you have a plus b to the 7th is you take this a to the n minus k times b to the k, multiplied by 7 choose 0, 7 choose 1, 7 choose 2, 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, and 7 choose 7. And that is where how you're going to expand your polynomial into, or your binomial into this. And notice how 7 choose 0 is plugged into this is 7 minus 0 is 7, but times 0 factorial makes the whole thing factorial, or 7 factorial divided by 7 factorial, which is equal to 1. So what this leads to a to the 7th, because 7 minus, this is pretty much simple math, but I just kind of want to show how everything worked out. And this little bracket means that the 7 choose 7 came out to be 7, the 7 choose 2 came out to be 21, 7 choose 3 came out to be 35, 7 choose 4 came out to be 35, 7 choose 5 came out to be 21, 7 choose 6 is 7, 7 choose 7 is 1. So you see how it goes 1, 7, 21, 35, 35, 21, 7, 1. And that gives us, I think it's a beautiful thing, and I don't know why I find it to be so amazing and beautiful, but it really is. And it's really fascinating to me how a series plus this factorial business, which can seem complicated at first, but it really isn't. It actually really is complicated, but not to do it. You know, it's simple calculated work. But I don't know, it's pretty amazing to me. And after doing all this, I kind of put the terms in order: a to the 7th plus b to the 7th plus 7a6b, a to the 6b plus 7a b to the 6th plus 21 a to the 5th b squared plus 21a squared b to the 5th plus 35 a to the 4th b to the 3rd plus 35 a to the 3rd b to the 4th. So it's almost just, I don't know how to describe it, but it really is amazing. So if you see I did something wrong, tell me, and thanks.